Hi, this is Aparna, and I'm here to deal with Geographic Resource Analysis Support System. Here are my details. Student ID 8623968080 and email ID has also been mentioned here. So the outline. Initially, I would be giving an introduction about GRASS GIS. The basics of GRASS GIS will be shown in implementation, and I'll further be carrying out terrain analysis and map calculation for the same dataset. Moving over to the installation process. So this is the official website of GRASS, where the installation procedure is mentioned in detail for each of the operating system, namely Mac, Linux, and Windows. So I have downloaded GRASS GIS 8.2, which is the recently released version for Mac, the one which got released on 6th June. So once this has been downloaded, we can easily launch it when it is in the application folder. Once launched, the terminal appears as shown. This makes it clear that the installation was successful. On opening GRASS, we get two windows, namely the map display window and the layout window. So, as I said, to talk about GRASS in general, GRASS is a 30-year-old open source software. It is being used by not just the geospatial community people, but it has also helped the US defense, also NASA. So here are a few points to add on to it. GRASS, as I mentioned initially, it expands for Geographic Resource Analysis Support System. It is a free and open source software. It is suitable for all kinds of geospatial data management analysis, graphics, and map production. It plays a vital role in spatial modeling. Moving on to the basic implementation of GRASS. So yes, initially, let's consider an already available data set, that is the natural earth data set. So how did I get this? There is this option where we can download the data set from the GRASS organization itself. So that's how I browsed and I downloaded this natural earth data set. Under that, we have several vector fields like coastlines, countries, lakes, lands, marine regions, and several other modules. Now, this happens when we have to switch to the current map set. So earlier, I have been using NYC, which was set as my current map set. Now I need to switch to the natural earth data set to be my current map set. So let me switch to the selected map set. So once I did that, the countries has been loaded into the map display view. Now I can further add on layers to it, namely say lakes, and that will be displayed here. Coastal lines will also be displayed here. So in order to differentiate, I can change the colors of coastal lines and lakes. So moving over to layers, this is where all the added layers appear. So on clicking this, we can either rename or go and check properties. The latitude, longitude of each of the countries will also be displayed. So considering this, let's move on to the color tab and change this to probably this or red. Click enter. Apply and okay. So all the coastal lines, as we see, is being colored in red. Similarly, for even the other two layers, that's the lakes and countries, it can be differentiated as shown. This is like the basic property of grass, loading a data set and loading a spatial data set and just exploring the tools. Now, I can perform several operations on this map. Namely, I can either, this is for panning and this is for zooming in. So let's say I want to select Africa. So this part gets zoomed in. Now let's say I want to change the width and height. Then I would choose this option. I can also add vector and raster legends to it, which I'll be dealing with in the next module. So these are like zoom in, PAM, and several other tools which are being given to the users by GRASS organization. Now moving on to the map calculation. This is the official page which is provided by GRASS on maps. So these are the available functions in map, like absolute function, the if clause, log function, mod function, and so on, out of which I will be demonstrating few here. There are also few null operations which is being supported by GRASS. Null doesn't mean that the value is zero, but it covers the exceptions like division by zero, modulus by zero, and so on. We also have few relational operators apart from the regular mathematical operations. So a few of the relational operators are like the ampersand, which we use in the if condition, in the if clauses, or condition, and so on. So let me show it in the demo here. So before moving on to that, we actually need a sort of computational graph to carry out this particular map operation. So in order to do that, let's say that we are calculating the slope. For that purpose, I'm considering the NYC Governors Island dataset. So this I have downloaded from the official website. Now let's move on to the permanent folder. And let's consider elevation 2017. Now again, we have to switch from what we were in before to this particular map. So I click on switch. So this is the NYC Governors Island graph on which we are going to perform certain mathematical operations. So firstly, let's calculate the slope of this. So in order to do that, we need to have a mask of the available map, which is displayed here. So let's create a mask of this. In order to do that, just click on raster and click on map option. You can name the map mask however you want. I'm going to name it as mask one. So now it has created command finished. So it has created the mask function right now. Now let's move on to the slope calculation. So over here, if we go to terrain analysis, there are several operations that we can perform, like least cost route, cumulative movement cost surface, generate contour lines, and so on. So here is what we require, that is slope and aspect. So name of the input elevation raster map. So in this, we have to choose elevation 2017, and the output can be stored as slope classes 1. And the others are optional for other mathematical operations. So now when we click on run, the operation is being performed. And here in the console, we see that the slope raster map is started and the command is being finished successfully. And the runtime of the command is also visible here. So this is the map which is displayed after calculating the slope. So in order to distinguish, we need to set up few legends for this map. So let me do that. So here is the option to set up legends. Add raster legend. Here we have to choose the raster map for which we want the legend. And I'm choosing slope classes 1, which we just created. Title is optional. Well, I'm going to give slope. Yeah, that's it. So click on apply. We can see the slope over here. And okay. So this is one of the many available terrain analysis which I demonstrated in this presentation. Now with this output, we are going to further proceed and do some map calculations on this. In order to do that, click on raster again. We can see this option called as raster map calculator, which has few more drop downs like simplified raster map calculator and raster map calculator. We will be using a raster map calculator. This is just like normal scientific calculator where we also have the relational operators here. So we are going to deal with if clause. So I'm going to click on if of x. I need to include this slope calculated map over here. So this I have named as slope classes. Yes, slope classes 1. So that is being included here. If slope classes 1 at permanent, if I have the values say lesser than or equal to 10, then I'm going to give it as allot the value as 1. Then this is the main if. Now I'm going to give another nested if. For the same slope classes. Say if the value is lesser than or equal to 20, then I'm going to categorize them under 2. Else it should be categorized as 3. This is the basic expression which I'm going to run now. We can now finally see the output of the calculated slope and the map calculation. So according to the if clause that is mentioned, all the dark violet regions here show the ones which are lesser than or equal to 10. And the second category is lesser than or equal to 20. And the last one is for greater than 30. It has been categorized as 1, 2, and 3, as I mentioned earlier. So this demonstrates GRASS, and this explains how useful the open source software is even in real-time applications. Thank you.